Hello and welcome to our lesson notes for Chapter 12, Lesson 2. We will be talking about surface areas of prisms and cylinders. And so we're going to explain what these things mean, what all the different pieces are, and we'll have some formulas that we use to calculate surface area for prisms and cylinders. The reason we group these together is because prisms and cylinders are very similar shapes to one another, or similar solids to one another. You can think of a cylinder as a circular prism. Even though that's not technically correct, it's kind of the basic idea. So let's look at some vocabulary here, and then we will talk about how to find surface area of a prism first. Alright, to begin, we're going to identify what a lateral face is, and you guys have seen this word here, and I've even used it in class, but I'm going to further explain what it is. A lateral face is any face of a polyhedron, or maybe a non-polyhedron, any face of a solid that is not considered a base. So if we have this, which would be a hexagonal prism, the hexagons would be the bases, then every one of these other rectangles would be lateral faces. Okay, faces that are not bases are called lateral faces. So the lateral area is the portion of the surface area that just includes those lateral faces. So it's the sum of all the areas of each lateral face. And we can find what that is this way. Okay, the lateral area of any prism is equal to the perimeter of the base. P is the perimeter of the base times the height of the prism, H. Okay, perimeter of the base times the height of the prism, H. Now you have to be careful because the base polygon might have a height measurement of its own if it's a rectangle or trapezoid or a triangle. So that height is not the same as the height of your prism. The height of your prism is the distance between the bases. I want you to write this in. Height of the base does not equal height of the prism. All right, write that down. Okay, and then height of the prism is the distance between the bases. It's very important that we understand that so we don't get confused. Alright, now in our first example we are going to actually calculate the lateral area of some prisms. Alright, so we have this hexagonal prism here. The bases are the hexagons. Okay, so I'm going to highlight those for you so you can see. This is a base. The other hexagon that you can kind of see towards the back would be the other base. Alright, since those are our bases, our lateral surfaces are all of these rectangles. We can add up those areas individually, or we can just use this formula. The lateral area of a prism equals the perimeter of that base times the height of the prism. Now, we have a regular hexagon for the base, where each side is 5. So the perimeter of a base is 5 times the number of sides, in this case is 6. 5 times 6 is 30 centimeters. So the perimeter is 30. The height is the distance between the bases, not up and down. The distance between the bases is this 12. That's the height of your prism. So the lateral area is my perimeter of 30 times my height of the prism, which is 12. 30 times 12 gives me 360 square centimeters. It is an area measurement, lateral area, so we use square centimeters for our unit of measure. We are going to start paying much more attention to our units of measure. I will start counting off if your answers do not include a proper unit of measure. Alright, so we have a regular octagonal prism, sorry about that, where the bases are regular octagons, where each side of the base is 3 centimeters, and the distance between these bases is 9 centimeters. I want you guys to try and find the lateral area by first finding the perimeter and then understanding what the height is, height of the prism. Find your lateral area of this prism. When you think you are ready, you can continue watching the video, so you might need to push pause to give yourself enough time to work this out. Alright, if you've had enough time, this is what we should get for our answer. The perimeter is 24 centimeters because each of the 8 sides of your octagon is 3. 3 times 8 equals 24. The height of your prism is the distance from one base to the other, which is 9 centimeters. So when I plug those into my lateral area formula, perimeter times height, I get 216 square centimeters. Hopefully that's the answer you got. If it's not, go back and watch that part and see if there's some mistake you made. If you're not sure what mistake you made, this would be a great place to write a little question in your notes to bring to class. All right. Now, as we talked about a second ago, lateral area is just a part of the surface area of a prism. The surface area of a prism includes lateral area, but then you also want to include both base areas. So the surface area of a prism is actually this formula. Okay. It's the lateral area, L, that we looked at how to find just above, plus 2 of the base areas. Okay, B is the area of whatever base shape you have. Lateral area, remember, is the perimeter of that base times the height of the prism. So we could write it out this way, or the full complete formula is this. Perimeter times height represents lateral area plus 2 times whatever that base area ends up being. We're going to want to remember how to find area of polygons like we learned last chapter. If the base is a rectangle, it's not too much of a problem, or a parallelogram. You'll also want to remember how to find the area of regular polygons using that 1/2 apothem times perimeter formula. Alright, so let's go ahead and try and find the total surface area. Notice we use the capital letter S to represent surface area, and capital letter L to represent lateral area, and capital letter B to represent base area. These capital letters help us understand that it's area that we're finding. Okay, we want to find the total surface area, capital S, for this rectangular prism. Now, as we've talked about with rectangular prisms, it doesn't really matter which two rectangles you call the bases, as long as they're congruent, parallel rectangles. So in this case, I'm going to go ahead and call the bases this 6 by 6 square at the front and the back. And again, I'll highlight those for you if you're having trouble seeing them. There's one base. There's the other base. That's what I'm going to call the bases. It's not wrong to call maybe the top and bottom the bases. It's just not how I'm choosing to do this problem. So remember, surface area is the lateral area, perimeter times height, plus 2 times the base area. So these are the 3 things we need to find. You can even make a table if you want. We need to know perimeter, height, and base area. Perimeter is the perimeter of the base. Perimeter of the base. Even if you want to write of base, you can. Perimeter of the base is the distance around the base. So the number of sides, you'll notice these are 6, these are 6. So we can assume these are both 6 centimeters apiece. So the perimeter is 4 times 6. Side length times the number of sides, 4, which is 24 centimeters. The height, remember, is the height of the prism, not the height of that rectangular base. The height of the prism is the distance between the bases. Since I called these two squares my bases, the height is the distance between them, or 12 centimeters. And then the base area is the area of one base shape, which would be 6. Again, right, area of base if you want, which would be 6 times 6, or 6 squared, which is 36 square centimeters. And now I'm going to find the lateral area, 24 times 12, plus 2 times that base area of 36, and simplify. We're going to multiply here and here before we add. 24 times 12 is 288, plus 2 times 36. 2 times 36 is 72. So when I add those together, I get a total surface area of 360 square centimeters. The unit of measure is important. We're going to skip example 3. We're actually going to do this in class. If you want to try and figure this out, you can find the surface area of this triangular prism. You're more than welcome to go ahead and try that, and that way you'll be one step ahead of us getting into class, but we will cover that example in class if you want to wait. Alright, so we do want to move on and talk about surface area and lateral area of a cylinder. It's very similar to the same process we just did, but with cylinders, we're going to use some different terminology. For instance, when it says the lateral area of a right cylinder, and we'll talk about the difference between a right cylinder and oblique cylinder because it's a little bit different. Right just means that one circle is directly above the other. If I were to connect their centers, that segment would be perpendicular to both circles. Okay, so the lateral area is 2 pi r times h. Well, let's talk about what those things mean. R is the radius of your circle. H is the height or the distance between the circles, but if you'll recognize 2 pi rh, that's the circumference of a circle. That's because circumference is the word we use in a circle to talk about its perimeter. The distance around the outside of the figure is circumference for circles. So we're still taking perimeter times height of the figure. To do surface area, we simply take that lateral area and we add 2 base areas. Remember, base area of a circle is pi r squared. When the base is a circle, the area is pi r squared. So we're going to add 2 pi r squared to that. So we can use these formulas as long as you understand they're still pretty much the same idea as our surface area formula for prisms. So we're going to do one of these examples and we'll do the other one in class. So we've got a cylinder here where the radius is 14. This distance, which would be the height, is 18. That's all we need to know to find lateral area and surface area. I want you to remember that we can find lateral area first and show that answer because it wants both, but then we're just going to adjust it a little bit, add to it to get our total surface area. Remember, lateral area formula is 2 pi r times the height, circumference times height. So we're going to plug in 2 pi, and then for the radius we use 14. For the height we use 18. And when we do that calculation in our calculator, if you need some time, pause the video. Otherwise, this is what we should get. 1,583.4 square feet. That's our lateral area rounded to the nearest tenth. You just do 2 times pi times 14 times 18. Surface area uses that formula 2 pi rh plus 2 pi r squared. But we already know that portion of it, and so we can just take that and add 2 pi times our radius of 14 squared. So we're really just going to do this and add it to that previous answer. So 2 pi r squared actually gives us about 1231.5 or 1231.5. So we're just going to add those together. And we get approximately a surface area of 2,814.9 square feet. All right, once again, you could probably do this problem part B on your own, and I challenge you to go ahead and try that, and then we will talk about that one in class and see if we can figure out that one. But again, it's just using the formulas and doing the work in the correct order.